Okay, so the third problem in that row on the first instructional resource is to determine the pattern and complete the table. Here we have an in and out table. So this is our in and out machine. These numbers are going into the machine. Inside the machine, there's a rule. Either we're adding something, we're subtracting something, we're multiplying something, or we're dividing something. And this number comes out of the machine. So in an in and out table, we're looking for a pattern. If I put 42 in, then 6 comes out. So if I have a bigger number going in and a smaller number coming out, that means I have taken some away. So I've either subtracted or I've divided, okay? So if I'm thinking in terms of subtraction, I want to know what 6 less than 42 is. So if I take away 36 from 42, that will give me 42. Let me check it and make sure I'm telling you. 36, 37, 38, 39, 40, 41, 42. So we'd have to subtract 36 from each. If I'm dividing, 42 divided by what number equals 6, then I can say, well, 6 times 7 is 42. So 42 divided by 7 is 6. For this to be my rule, it has to work in all three places. If I have 35, can I take 36 away from that? No. So if I can't take 36 away from it and get a positive number, that cannot be my rule. So my rule has to be divided by 7. If that is true, then 28 divided by 7 equals 4. Well, let me check it. 4 times 7 equals 28. So my rule here is to divide by 7. So in order to get my missing number, I need to take the number that I know going in, 35. Sorry, I wrote on that line. Divide it by 7, and I will get my number coming out. What number times 7 equals 35? 5 times 7 equals 35. So the missing number in that one is 5. Okay, so the next problem has a fraction circle, and that fraction circle is split into 5 equal parts. So pretend those are all equal, guys. You know how to use your imaginations with my artwork, so it's all perfect. It says, which fraction is equivalent to the shaded part of the fraction below? So in our fractions, our numerator needs to be how many shaded parts? 1, 2, 3, 4. And our denominator has to be how many total parts? So 1, 2, 3, 4, 5. Now, it's asking me to make an equivalent fraction. It says which fraction is equivalent to. 4/5 is that fraction. You could also make an equivalent fraction by multiplying by the same number on top as you do the bottom. 4/5 is a back-to-back number, so we can't divide. If these were bigger numbers that weren't back-to-back, we could find a greatest common factor and divide by the same number on top as the bottom. Division and multiplication are the only two ways we can make equivalent fractions. Here, they're back-to-back. It's already simplified, so we have to multiply. You can multiply by 2 and get 8/10. You could multiply by 10 and get 40/50. Either way, it is an equivalent fraction as long as you do the same on the top as you do on the bottom. So the next question is on the bottom row, and it says to draw an example of a line segment. Now, if you're doing your work on the computer, there was no way for me to allow you to draw those. So what I did was give you some multiple choice, and you had to choose which one. So when we went over lines and line segments, we talked about how a line goes on forever in both directions. So it has the arrows on both ends. But a line segment is as if, we took and cut a piece of that line out and brought it down. So it's a piece or a part. So that word segment means piece or a part of. A segment of a cake is a piece of cake. So a line segment should have 2 endpoints on it because it doesn't go on forever in any direction. To name it, we have to give it some letters of the endpoints, and we name it by those endpoints. So this is line segment A, B. So as long as your line segment is a piece of a line that has 2 endpoints, you have created a line segment for that one, just like it asks. Now the next question, I'm going to go ahead and do it on this one too because it's kind of short, asks which shapes are congruent. A, B, C, and D gives you different options. To be congruent, the shapes have to be the same shape. So that rules out A because A shows a square and a rectangle, and those are not the same. B, C, and D have the same shapes, but to be congruent, it has to be same shape and same size. So in B, we can slash that trash because we have a large square and we have a small square. C looks like it could be the same size and shape, only one is turned, so we'll go back to that one. D is 2 triangles, same shape, but they are made different. One is an acute triangle with very small angles, and one is a right triangle with right angles. So C is the correct answer. C has a pentagon. The only difference is that the second pentagon is turned a little bit. It can be turned as long as it is the same shape. Like I said, pretend. Same shape, same size. Okay? So it can be turned.